So in this video, we'll look at the different types of energy sources which we normally use in EV. So we have a quick video on energy sources for EV. Good morning, class. Today we begin our journey into one of the most critical components of electric vehicle, the energy storage system or ESS. Now, who can tell me what is an electric vehicle? It's a vehicle that runs on electricity instead of petrol or diesel. Exactly. And where does that electricity come from? From the battery? Correct again. The battery is the heart of the EV. It's what stores the energy that drives the motor. That battery system include all supporting components is what we call the energy storage system. What is an energy storage system? So let's define it. An energy storage system or ESS is a combination of components that store energy for later use in powering electric motors and other vehicle systems. Energy storage system store and manage energy to power the electric motor, support regenerative braking, and increasingly to integrate with smart grids and renewable energy. Importance of ESS in EVs stores primary energy for motor and electronics, supports acceleration and regenerative braking, improves energy efficiency and driving range, enables fast charging and grid interaction, determines safety, cost, and lifespan of the EV. Types of energy storage system in EVs. Let's explore each major type used or being explored in EVs. Lithium ion batteries. Most common ESS today, high energy density, which gives more range, fast charging, lightweight, but sensitive to temperature, risk of fire, expensive raw materials. They are normally used in all modern EVs such as Tesla, Hyundai Ioniq, etc. Next, solid state batteries, the next generation battery technology in development. Higher energy density than lithium ion, solid electrolyte, so it is safer, no leaks or fires can happen, longer cycle life, but it is expensive and hard to manufacture. It is not yet commercialized, it is still in development stage. Most of the Toyota and BMW prototypes are thinking of including solid state batteries in the future EVs. Supercapacitors store energy electrostatically and not chemically. Ultra fast charging and discharging, excellent for high power burst, mainly during acceleration, very long lifespan, but it has low energy density, which gives limited driving range. Cannot serve as the main ESS alone. You cannot have only supercapacitor as the primary energy storage system in a vehicle. It is normally used to boost acceleration, regenerative braking support, and hybrid storage with batteries. So, supercapacitors are like the sprint athletes of ESS. Great analogy. Batteries are marathoners, whereas supercapacitors are sprinters. Next, fuel cells or hydrogen fuel cell generate electricity via chemical reaction. Hydrogen plus oxygen gives electricity plus water. It has zero emissions, only water vapor, fast refueling like a gas car, good range, but it is expensive because it needs platinum catalyst and also for hydrogen storage requires extra cost. Hydrogen infrastructure is limited. It is normally used in Toyota Mirai, Hyundai Nexo, commercial trucks, and buses. So, fuel cells don't store energy, they generate it on demand. Exactly. Think of them as onboard power plants. Next, flywheel energy storage stores energy in a rotating mass, mainly mechanical energy. Extremely fast energy release, long life, low maintenance, environmentally clean. Low energy density, but it has low energy density, heavy and complex system integration is needed. It is used for performance EVs, regenerative braking system, experimental transport, for example, trains. Can a car actually run just on flywheel? Not for a longer distance. Flywheels are best for short, high power applications like capturing braking energy or boosting acceleration momentarily. This is the comparison of different types of energy storage system with respect to energy density, power density, charge time, cost, lifespan, and also with respect to its application. You can take a moment, pause the video to understand the table given. Some EVs and heavy duty vehicles use hybrid ESS. For example, battery plus supercapacitor, which combines the range plus quick burst. Fuel cell plus battery gives you longer range and flexible energy buffer. Flywheel plus battery, fast braking energy recovery plus main drive. To sum up, no single ESS is perfect. Choosing the right storage system depends on cost, vehicle type, range, and usage. The future lies in hybrid systems, solid state technology, and sustainable materials. Professor, which ESS is the most suitable or sustainable? Good question. Fuel cells emit only water, but hydrogen production is energy intensive. Batteries are improving in recyclability. Flywheels and supercapacitors have very long lifespans with minimal waste. Sustainability depends on the full life cycle from materials to disposal. Thank you.